This is a Research Infrastructure Services instructional video.
All right, looks like it's 1:45 now. Give people a couple minutes to get logged in. Looks like there's still some people signing in. Thanks for joining us this afternoon. Just a reminder that set your first and last name so we can record you. We're going to be recording this session too, so we'll be providing all the content that you see after the meetings. And if you need to ask questions in the chat, we have people monitoring the chat. We'll help you answer those. So this seminar that we're doing is an introduction to Docker. If you were on the last one, I mentioned a little bit of the history of HPC and why we're using Docker and why it's important. So it sort of gets around to the dependencies, application management, updating the system OS, and making it secure and tying it to the latest hardware. So those are a lot of things that those integration points are management issue for both the systems and the users. And so people want to evolve at different paces, and Docker essentially allows us to do that. We can run a secure base image with the latest hardware drivers and keep it up to date, and you can build and run your own applications against your the operating system of your choice. And the reason why this is also really important is for scientific reproducibility, and you sharing your code and your with your community, and taking your code with you in your lab with you. If you think about your container is almost your digital virtual laboratory, and something that you can easily share and reproduce and take with you and run anywhere. And so that's some of the reasons why we're using Docker, and why it's something that you should too as you move into the risk computing. Maybe you're a traditional HPC user and you can use some of the environments and applications that we can provide. But if you wanted to get into more cutting edge software development, you were going to be interested in using and leveraging Docker. So with that, I'm going to turn it over to Chandler Prince to introduce you to Docker.
All right, welcome to my workshop on how to build, tag, and push a custom Docker image. There is a URL for this that I put in the chat. It should be accessible if you're on the VPN. I'm not expecting everybody to follow along while I'm doing this presentation. I'm kind of assuming that you'll either follow the directions later, or if you prefer, you can click this link and you can actually follow along with my YouTube video where I'm basically doing this presentation as you're going to see it today. And then you can pause it and fast forward, rewind as you needed. So the actual presentation I'm doing today will be a little bit faster. The prerequisites in order to follow along with this would be a willingness to learn, a Docker Hub account, and they have a sign up page, which shouldn't be not too hard to figure out. And Docker Desktop. So if you are on OS X, which is Mac, or Windows 10 Pro, you can just click these buttons and follow the directions and everything should work out of the box. If you're on Windows 10, but it's not Pro, I heard that there's going to be an update sometime this summer. When you get Windows Subsystem for Linux 2, it should actually fix the issues people are having on Windows 10 Home. So in the future, you should be able to follow it for Windows 10 as well. And if you're on Linux, I have directions you can follow right here. It's actually right in Docker's documentation. And it'll tell you how to install it on CentOS, Debian, Fedora, Ubuntu. Of course, you would have to have administration privileges. All right. So with that, I am going to go to my IDE. So this is a text editor. It's called Visual Studio Code. It's open source and it's freely available for anybody to use. And I like using this for Docker files because they have a Docker extension, which there should be a link to in my presentation materials on Confluence. And this gives you really handy, useful autocomplete stuff. And you notice how I just hovered over from. It'll actually give you examples of what from means and how to actually, how the syntax works. So for example, here it says from. It sets the base image to use for subsequent instructions. From must be the first instruction in a Docker file. So when you're using containers, you're using something that's already using a Linux kernel. But on top of that, you have to add extra things into it, like extra things for a Linux distribution. So I like to pick images that have as many of the dependencies I need as possible. And I try to select small images. And you might be wondering, how do I figure out what that is? Well, you can go to Docker Hub. Docker Hub actually lets you search for images. So I already know from previous research that Debian and Ubuntu use the libraries that I know I'm going to need in order to install Python and R, and they both have official images. So I can select Debian like I just did now, and then I can go look at tags. Now I happen to know that the latest tag for Debian is a little bit bigger than another version of Debian that I want to use. So I've already looked into it, and I found out that stretch slim is about half the size. So, I just go here, I can copy that and paste that, and I just pasted that right after my from instructions. So it says from Debian stretch slim, and I had the version of Linux that I wanted to use, and it's only 22 megabytes compressed. So after you've chosen your base distribution, you have a run command. And the documentation, it says it executes any commands on top of the current image as a new layer and commits the results. So what I'm using is the apt-get package manager. And this is the same for both Debian and Ubuntu. And I like using this because it's pretty a popular Linux distribution. So if you have Debian or Ubuntu, you should be able to find information about how to install various programs. So we always start with an apt-get update. And what apt-get update does is it actually gets links to the latest software that you're going to install on your distribution. So I always run this right before apt-get install. So and means it's the next command, and it's apt-get install. You have to give it this -y flag, because if you were running in a Linux distribution and you run apt-get install, it's going to say, do you really want to install this? And you're going to have to manually type Y. If you use this -y, it does that for you. If you don't use it when you're doing a Docker build, it actually just fails to build completely because you can't enter Y on the fly. After that, I've used this flag called no install recommends. And this really is just there to make sure it doesn't install extra recommended software that isn't needed. It saves space in the final image. And so finally, I'm going to where I'm actually installing 4 different pieces of software, or 4 packages. So I'm installing RBase and RBase Dev. So I basically had Googled at some point how to install R on Ubuntu, and I heard that RBase and RBase Dev were going to be the best for my use case. Similarly, at some point, I needed to know how to install Git. So I either guessed it was apt-get install Git, because it often is like that in Python, or perhaps I looked it up. And Python was probably the trickiest one because there's 2 versions of Python. There's Python 2 and Python 3 out there. So I actually looked up how to install the correct one. And I think I can't quite see it underneath what Zoom is giving me right here, but I can bring it up. I Googled the Debian wiki on Python, and I found out how to install Python here. And I saw that Python 3.5 and 2.7 were available by default in Stretch. And I found out the syntax was just Python 3. So I added that in here. So I'm installing R, Git, and Python 3. And finally, after all is done, there's an optional command I'm running, which is apt-get clean. And this saves space in your final image. So I think when I ran it with and without the last time, it was like 30 megabytes. So this may be not huge, but how big it will be really depends on what you're installing. So after that, I have another run command. In this case, I'm actually cloning down a repository I have made that has a Python 3 hello program. It literally just prints hello to the terminal. So this is going to clone it down, and you'll find a lot of researchers will use git clone in order to install things. And I see a few people are putting questions in the chat, so I'm going to pause right here and see if there's anything I need to answer.
I think there was a question about compiling from source. And how do you compile source code? Special CPU instructions.
That's certainly going to get a little bit more complicated. I don't think I can answer in this workshop. Maybe someone in chat from our team might be able to answer that directly, but that's definitely out of the scope of what I was hoping to cover in this workshop.
So essentially there's two ways you can do that. I'll answer it real quick. You can do it as part of the Docker build process, kind of what you run, and Chandler will get into that in a bit, I think. Or you could just compile your code as you would typically if you had, say, GCC installed. You can compile a code against the a clustered node within your image. So there's a couple of different ways you can do it actually, and there's different pluses and minuses of doing it either way.
All right, so I will go on to the next step, which is do a Docker build. So in this case,
1 second, Chandler. We got a couple more questions I want to jump into. The one is, are the compute nodes homogeneous? So long as I build on the cluster, will be fine. So we've got CPU and GPU, and if you build it in a CPU, then it will be fine as long as you're running CPU. If you need to use GPUs, then you'll have to do that and use those GPU clusters. And then can I run Dockerize and provide the dependencies needed? I feel the answer to that is yes, but maybe somebody here knows better than that. Chandler or Craig, have either of you ever used Dockerize?
I have never used Dockerized, but if it's something you want me to follow up on, you can either put in a service desk ticket or someone could email me. Would you like me to give out my email information?
Nah, that's okay. We'll just do service desk.
All right.
Okay, Chenglu, we'll try to get that answer to you a little bit later in this chat. I'm going to do a little bit of digging to see, but I'm not sure if I can answer you or not.
All right, so in order to build this file, this Docker file, we have the Docker build command, and I've done Docker build with a -t, which means I'm actually tagging it at the same time. So when you tag a Docker file, you need to use your username. So in this case, I'm Chandler Prince, that's my username. You would have your own username that you create when you sign up for Docker Hub, or if you already have your username, and that's where you would put this. Then you have a /, and after this /, you have to name your image, right? So in this case, I've named it something a little bit lengthy, which is Python_git_r_hello. And then if you don't put an image tag on it, it will actually default to latest. And this dot at the end is actually telling you, telling Docker where the Docker file is, and it's in the current directory that I'm working in. So I run a Docker build, and this can take a while if you are doing this for the first time. So in this case, I've run this before, and I already have Debian Stretch Slim on my computer system. You'll see it says, this is cached right here. So again, this can take about a minute on most people's machines, could be longer, could be faster. And then it's using the cache here. But at the end, you'll see that it has successfully tagged this as Chandler Prince, Python_get_r_hello with the latest tag. So the next step that I always run after I have tagged an image is to run it locally on my machine. And one reason they do this is because Docker on LSF and Compute One isn't exactly the same as it will be on your machine. There are things about how LSF and the Docker wrapper and security that make it slightly different. So I always like to make sure it runs on my machine first to make sure that there's nothing that's interfering. So I will do this. All right, so I've got the Docker run command, and the Docker run command has a -it, which means it's interactive. It's an interactive terminal, and it'll actually show me the print statement. And then I've got my username for the Docker Hub, a /, the image name, and then I could include the tag name latest, but if I don't, it's again the default. And then I'm saying what I want to use to interpret the code, which is Python 3. And finally, I'm giving it the path to my code. So in this case, when I did a git clone, there was a python-hello directory. And inside that directory, there was hello.py, which is going to print hello py. So I press enter, and you'll see it runs just fine on my local machine. So I'm like, oh, okay, I'm good to go. So now I can push it. And then when I go to Compute One and I pull it down, I think it should run. So to push it, it's very similar to the commands I've run previously. So it's docker push, my username, the name of the image, and then I've given it the tag latest, which you can remember is the default we're seeing up here. All right, so I'm pushing it as latest. This can take a while. In this case, I have already pushed it previously, so it didn't take much time at all. But it just, will take maybe about, it depends on how big your image is. It could take a while if you have a big image. All right, so from here, I need to SSH into Compute One, and I've already done that in a terminal, which I have right here. So I'm in Compute One already, and I need to run the bsub command. All right, so the bsub command is as follows. It's bsub -_g compute IRS, and that is something that you probably won't need. Actually, you shouldn't use if you're not in the compute -RIS group. So if you're only in one group, you wouldn't need to use this at all. You could get rid of it completely. I'm in 2 groups, so I need to have this. If you're in 2 groups, you would need to figure out what your group name is and add it in here. And then I've got a -is flag to indicate that it's interactive. And then I've got -q, which tells me which queue to use. So in this case, we've set up a special queue just for this workshop, which is workshop interactive. Then there's this flag -a to indicate that it's an app. Then we have our Docker wrapper. And you'll see again that I have my username with a /, the image name, and then finally, right here at the end, I have the tag. And then just like before, I'm telling it it's going to use Python 3, and I'm giving it the path to my executable. So it's submitting to the queue. It's downloading the image. It's running it. And it's printing hello to the terminal. Now I know I did this a little fast, and I'm sure there's a few questions I'll have to answer. So I'm going to bring up the chat and find out what people have answered and what questions are still out there.
We're actually fairly caught up in chat questions, but this might be a good time for people to raise their hand if they want to ask a question out loud or type in a quick question if they've got anything that they want to say.
Can I pull from other people? Yeah, the simple answer is if it's publicly available, you can pull it really easily. So I can pull in any image I want, as long as it has a shell. So if I went to Docker Hub, sorry, this overlay on the top of my screen makes it actually kind of hard to see and work in Docker Hub, but I could pretty much, go say, oh, this is Alpine Linux. And I could go ahead and just pull this because this is publicly available. If people have publicly available software, then you can use it too. Like we've got Miniconda. So this would also be, available, and you could pull it down the same way I just did.
Question about, are there other keywords we should know other than from and run? You probably want to also pull. There's a few things. There's some basic Docker stuff you should look into. There's a really, really good Docker tutorial that's out there that I believe, Chandler, you have the link to it in some of your documentation.
I believe so too, but some of the best Docker tutorials are actually directly from Docker. So I could find them pretty quickly. Oh, I'll just Google Docker tutorial.
While you're doing that, we've got a fundamental question. What is the point of using Docker? Can I simply not compile my program and call it as an executable? In a traditional HPC, that's what you would do, but in a Docker environment, you are going to need to set up your environment, and that's what Docker is doing. So Docker allows you to set up a custom environment that's exactly what you want. You're not tied to a specific HPC environment. It also means that your work is not tied to that particular HPC. It makes it easy to move it into the cloud or give it to any other institute that has a Docker environment.
But the answer too is, yeah, I mean, you can just, compile against, using the, install compilers in Ubuntu and compile your code and execute it. So yeah, it's as easy as that.
I think one thing I can't remember if people have touched on today at this workshop is that containerizing your research applications means it's really easy to run anywhere, which means that if you wanted someone to reproduce your research, you could, say, hey, this is the software I used. It has all the dependencies already contained within, and it would be fairly easy for them to bring in the data themselves and reproduce it.
Okay, that looks like all the questions currently, if you want to move on.
I was actually expecting there to be more questions. That's actually the end of my workshop right there.
Okay, well, we've got quite a bit of time before the end of the session, so let's see if we've got some more questions. Bridget Arasconi asks, is there a way to modify a Docker image that is already public? Chandler, you want to grab that one?
So, yes. There's different ways people could have made it public. It could be that you can see the actual code for the Docker file in the repository, in which case you could just, copy over their Docker file and edit it there. Or it could be you could build upon someone else's Docker image, which is actually what I was just doing right now. So basically, you know how I'm saying from? You could do that with any image, and you could add things on top of it, just like I have here. So you could run anybody's image, and then afterwards, git clone on top of it, copy things in, install extra dependencies you have. It just becomes an issue of whether it's, you'd have to know if the operating system is Ubuntu or Alpine or something like that, and you have to know how to install things. But yes, you can basically add on anybody's publicly available image.
So we actually got quite a few questions. Next one is, can I git clone and run Docker build on the HPC? And so I think the question there is, we've got CHPC, and then we've got our traditional HPC that we just showed you earlier, and then we also have our compute cluster that runs Docker. If you're running Docker builds, then generally you would want to be doing that on just the standard compute one cluster. Next question is, can you show us how to perform a Docker login on the cluster? That may be out of scope, Chandler, but if not, that might be a thing you can show real quick.
Yeah, it's not something I've done recently. I'd have to actually look up the instructions, which we do have in our documentation. I don't have it memorized. It's not something I can like literally do. Maybe, did Catherine just say she dropped the link above, or was that for something else?
Yeah, she did. She dropped the link.
Okay. It's definitely something that we have directions how to do in our documentation, but it's not something I have memorized that I can do right in front of you off the top of my head.
So John Martin asks, are there downsides to loading an image, using Docker run to run it interactively, go in and manually add software and then save it out? Or is the preferred method always building a Docker file and creating a container?
Yeah, I'd say the preferred method is definitely to create a container. I do seem to recall there is a way to save the state of your container, but it's not particularly common to do, so I haven't done it very frequently. Usually when I've done manual installs, it was mainly just to test to see if something was going to work or how it was going to work and what the syntax was. And then I ended up replicating it in the Docker file.
Atul asks, can we take somebody else's Docker file, change their image, and update as a new version? In general, you would, if you've got access to their source code, you would take their source code, make those changes, and then you would have your own branch that would be yours at that point.
Yeah, I think that's a good explanation. Like you'd have your own username and you would be pushing it to your own, you know, private or public repository with your username. It wouldn't be updating their exact image. Yeah, Sean's hinting at image size being an issue. It could be an issue every time you're pulling things down when you're doing research on Compute One. If you have, you know, a 2 GB image, that means every time it hits a blade where this image hasn't already been cached because it's been downloaded recently, you're going to have to wait for it to download every time, and that's going to slow things down. When you do things faster, it's both more secure and it's going to be a lot faster and easier to do, less costs.
We've got a couple more minutes if there's any other questions. Otherwise, our next workshop got moved to 2:45 to give people a break between. So I'll keep this open for a couple more minutes to see if there's any last questions. And otherwise, we'll see everybody who's in the next one in a few minutes.
$2:45. I'm wondering if Rahul has the link already, or if someone's able to provide that for him.
I can put the link into the chat, but yeah, and again, if there are any questions, this is a good time to ask them because we've got time in our schedule right now.
Yeah, it originally was scheduled for 2:30, and we decided it was a better idea to have more time in between presentations in case things went wrong.
And it is 2:30. Yeah, 2:30 is the time it starts. It was going to start at 2.
Oh, okay.
We moved it to 2:30.
Sorry.
Yeah. Sorry about that. How do you add in a license for Stata is a question. So Ideally, we would have a license manager that would manage that for you. Short of that, we are working on various applications that use licenses. It's not a trivial question. It depends on the product, and I don't know Stata personally as to how you do your licensing there.
Yeah, another issue with that is you could put the license within the container, but you obviously don't want to make that publicly accessible. We are working on a private registry to hold applications like Stata or things that may have a license contained within the container, or we need as Marshall mentioned, a license manager. Those are all things in development currently.
So that actually brings up a really good issue. You said you wouldn't want to have license keys in a container, and that's true, but you also wouldn't want to have any, let's say if you're working on sensitive data, you wouldn't want to have that sensitive data in the container either. You'd want to be bringing that in by mounting volumes, and you definitely don't want that to be permanently in your container.
Yes. What about passwords?
You definitely don't want passwords in your container either. Unless you want to share those, unless you want to assume that those are freely available for everybody anywhere who is good at looking around your container.
Okay, that looks like we've, oh, another question. Do you have to use reference genomes? Do you have to load those in the container? I would say generally your container would have your tool set available, and then you would, once you're there, you would mount storage that points to those reference genomes, and then you would do your work there. So you should not put your reference genome inside your container because, as John just said, it will make your image gargantuan. Like, if you're working with terabytes of genomes, you don't want those in your container. Okay, I'm going to call this right now. We'll see everybody at 2:30 in the next Zoom meeting, and we'll go from there. Thanks, everyone.